Welcome to the Explainer. Today, we're diving straight into the absolute foundational toolkit of the modern web, REST API methods. If you've ever found yourself wondering how applications actually talk to each other to create, update, or just seamlessly delete data behind the scenes, well, you're exactly in the right place. We're going to break this entire toolkit down piece by piece to give you the ultimate guide to HTTP methods. Let's get into it. Here's our roadmap for today. We'll start with what are REST APIs, move on to reading and creating data, then updating and deleting resources, metadata and discovery methods, understanding idempotency, and finally, decoding HTTP status codes. Section 1. What are REST APIs? The foundation of client-server communication. Okay, so at its core, a REST API, which stands for Representational State Transfer, is basically just a way for applications to communicate over standard HTTP. The setup is beautifully simple, really. A client application sends an HTTP request, and the REST API server processes it and fires back some data, usually in JSON format. Now, there are two absolutely crucial things to keep in mind here. First, these interactions are entirely stateless. That means every single request exists in a vacuum. It's completely independent. The server isn't sitting there remembering your previous request. And second, they use resource-based URLs. The URL literally represents the thing you're interacting with. And the standard HTTP verbs, which are the methods we're about to explore, define the exact action you want to take on it. Section 2. Reading and creating data. The start of a resource's journey. Let's start with the workhorse, the most common method you'll ever encounter, GET. This one is strictly used to retrieve data from the server. It's 100% read-only. So for example, if you send a GET request to a URL like /users/101, the server is going to respond with a JSON object, maybe letting us know that user 101 is named John. Because GET doesn't change a single thing on the server, it's considered a safe method. And here's a pro tip. Because it's safe, the responses can actually be cached to massively improve your application's performance. That is exactly why your social media feeds load almost instantly after you open them the first time. But what happens when we want to actually add something new to the mix? Well, that's where POST steps in. POST is your go-to method for creating a brand new resource on the server. So if we fire off a POST request to /users and attach a JSON body with the name John, the server takes that, creates the new data, and responds back to tell us, hey, a new resource was created, and usually hands us back a brand new ID, like 101. It adds data, literally kicking off that resource's existence. Section 3. Updating and deleting resources. Modifying and removing data. Now, this next method is incredibly interesting because of how specific it is. Put is used to completely replace or update a resource. Let's say we send a put request to /users/101 with a new name, John Smith, and an email address. The server just swaps out the old record entirely for this new one. But watch out, because here is the critical trap that catches so many developers off guard. Put replaces the entire resource. If there are any fields you forget to include in your request body, the server will literally just wipe them out or reset them to default values. It's a total overhaul. So what if you don't want to nuke the whole thing and start over? You reach for patch. Just like it sounds, patch is used to partially update a resource. If John just needs to quickly update his email address to newmail@example.com, you just use patch. You only send over the specific tiny fields that actually need to change. Because you aren't forcing the entire user payload back and forth over the network, patch uses way less bandwidth. It's basically your tool for incredibly efficient surgical tweaks. And this, right here, is the classic showdown that trips up devs all the time. On one side, you have put. It demands all your fields because it's doing a full replacement. On the other side, patch. It only asks for the changed fields to do a partial update. Understanding the difference between these two and choosing the right one is honestly the secret to building a really clean, highly efficient API. The absolute final step in this main lifecycle is the delete method. As you'd expect, this is used to permanently scrub a resource from the server. If we call delete on /users/101, John's record is totally wiped. Usually the server will hit you back with a 204 no content status. That essentially means, hey, the action was successful, but I've got absolutely nothing left to say to you. The data is just gone. Let's just do a quick summary of that core journey to really lock it in. Think about our user management API. Notice how the base /users endpoint handles your bulk actions like get and post. But the second you add a specific ID to the end, like /users/101, you are now targeting specific single item actions like put, patch, and delete. It's a beautifully logical, highly structured system once you see it laid out. Section 4. Metadata and Discovery Methods. The behind-the-scenes tools. All right, let's look behind the curtain. First up is the head method. Now think of head as being the exact same thing as a GET request, but with one massive, crucial difference. The server returns only the response headers, with absolutely zero body data attached. So why on earth is that useful? Well, you can use it to verify a resource actually exists without wasting precious bandwidth downloading the whole thing. You can check content metadata, like finding out the size of a giant file before you commit to downloading it. Or you can use it for cache validation, basically checking if the data you already have stored locally is still fresh based on the server's last modified date. Next up, we have options. This is essentially your app politely walking up to the server and asking, hey, what are my capabilities here? It returns the HTTP methods that a specific resource actually supports. So if you fire an options request at /users, the server might respond with an allow header listing get, post, put, and delete. Browsers use this heavily for CORS pre-flight checks, which is basically just making sure cross-origin requests have the right security permissions before they start slinging sensitive data around. It's also just great for general API discovery. Section 5. Understanding idempotency, the rules of repeating requests. Now we need to talk about idempotency. It's a big, fancy-sounding word, but the core definition is super straightforward. An idempotent method produces the exact same result no matter how many times you repeat it. Think of it literally like the remote control for your TV. If you press the mute button, the TV mutes. If you sit there and mash that same mute button 10 more times, nothing changes. The TV just stays muted. That specific action is idempotent. The great news is, most of our REST methods are wonderfully idempotent. If you get a user 10 times in a row, you just get the same data 10 times. If you put an update 10 times, it just replaces the data with the exact same update over and over. Interestingly, even delete is generally considered idempotent. Think about it. If you delete user 101, they're gone. If you accidentally send that exact same delete request a second time, the server will just return a 404 not found error. Yes, the response code is technically different, but the crucial part is that the state of the server remains exactly the same. The user is still deleted, so repeating the call is completely safe. But you really have to be careful here, because post is the major exception to the rule. Post is non-idempotent. If you send the post request with John's details, the server creates a new user, let's say it's ID 101. If your app glitches out and accidentally fires that exact same post request twice, the server doesn't just overwrite it. Nope, it creates a clone. You suddenly have two users with the exact same details and a massive headache for whoever is managing your database. Repeated calls create duplicates. That's why handling your post requests properly in your code is so unbelievably important. Section 6. Decoding HTTP status codes. The server's feedback loop. Every single response you get back comes with an HTTP status code, and they're grouped into handy categories. The 200 series, that means success, high fives all around. A standard 200 means everything went perfectly. A 201 created is the holy grail you want to see after a post. And 204 no content is super common after a successful delete. Then we move to the 400 series. This is basically the server's way of saying, look, it's not me, it's you. 400 bad request means your input was messed up. 401 unauthorized means you aren't logged in, while 403 forbidden means you're logged in, but you definitely don't have the permissions for what you're trying to do. And of course, the legendary 404 not found just means you're looking for a ghost. Finally, we have the 500 series. This means the server actually had a meltdown, and the issue is completely out of your hands. And honestly, just like that, you have completely mastered the foundational tools of web communication. You now know exactly how to read, create, replace, tweak, and delete data. You know how to check metadata safely, you completely understand the vital rule of idempotency, and you can fluently read the server's status code feedback loop. These are the literal methods powering the entire digital world around you every single day. So the next time you hit submit on a web form or pull down to refresh a feed, you're going to know exactly what's happening under the hood. Which leads me to my final question for you. Now that you hold the keys to the internet's toolkit, what are you going to build next? Thanks so much for joining this explainer, and happy building.